What's up, guys? Welcome back. We're going to talk about the planets today, the planets that are in motion around the sun. The word planet comes from the Greek word meaning wanderer. So even though many planets don't emit their own light, we can see the planets due to their reflecting of the sunlight. Mercury, Venus, Mars, Jupiter, and Saturn are all viewable by the unaided eye. You can see them. Uranus, for example, is too faint for it to see. Neptune is never bright enough. All right. And so we can't see those. From the viewpoint of the North Celestial Pole, we could see that the planets move kind of counterclockwise around the sun. All right, and the furthest planets move the slowest. From Earth, the outer planets move along the eastward along the ecliptic. So if you were looking due north, you would see them kind of going around the orbit. All right, because the orbits of Mercury and Venus are inside Earth's orbit, their apparent motion as viewed from the Earth is different from the outer planets. They first appear to move eastward, then westward, then back again. So this is kind of where you get maybe this idea of Mercury in retrograde, if you've ever heard of that. There's some pseudoscience related to that we'll talk about as well. To find the innermost planets, we need to look above the western horizon just after sunset or above the eastern horizon just before sunrise. So you need to be able to see them when the sun is just about to go down or just about to come up. Venus is easier to spot because it's so bright. It travels higher above the horizon than Mercury does as well. Any planet visible in the evening sky is called an evening star. Any visible planet in the sky in the morning, right around sunrise, is what we call a morning star. So one of the things we learned about is the seasons, and they're being produced by the motion of the tilted Earth around the sun. And I did an example in class with the pumpkin sitting next to me. But there are also more subtle motions that have dramatic effects on the Earth's climate. These things change what's going on. The Earth has gone through at least 4 ice ages. Different things that are going on with climate change. All of them can be attributed to these different things about the Earth. We're still living in an ice age technically, but we find ourselves during an ice age when the Earth is slightly warmer. This warming began about 12,000 years ago. So what causes these ice ages? How are they related to the motion of the Earth? Well, in 1920, Milankovich, I always have a hard time saying that, proposed his set of hypotheses. They state that these small changes in Earth's orbit, Earth's precession, and inclination all affect and can cause these ice ages. So due to gravitational interactions with other planets, Earth's elliptical orbit, start with that, varies slightly over a 100,000 year period. When the orbit is more elliptical, this can change the amount of solar energy that reaches the Earth. You're basically moving in that diagram I did with the flashlight, you're moving the flashlight closer or further to the sun, or to the Earth, excuse me. All right. The Earth's tilt. The Earth's tilt is currently at 23.4 degrees. It also varies. It can be between 22 and almost 25 degrees over the course of about 41,000 years. It's due to the gravitational attraction of the moon and the sun and other planets and everything kind of weighing on this tilt and pulling it further apart or further back. All right, that's called the precession. Or that's called inclination, excuse me. The precession is, we've talked about this before, is the Earth spins like a top. And it kind of wobbles a little bit. This is a 26,000 year period, and it affects the seasons. It affects where the Earth's orbit points, and a particular hemisphere experiences the seasons. At the moment, our northern hemisphere, summer occurs when the Earth is further from the sun than average, and when the northern summers are slightly cooler. All right, so these things change the way that the Earth experiences the solar energy. So even though Milankovich proposed this hypothesis in 1920, there was no evidence really available to support it. It took a long time for his ideas to come up, almost until the mid-1970s. They took long cores of sediment from the ocean floor, and they used them to determine the temperatures for different times in Earth's history. And this temperature matched what was predicted by his model, as you can see in the slide up above. So predicted solar heating, observed ocean temperatures, and you've got these peaks and valleys almost lining up pretty perfectly, although maybe not so dramatically as they would have expected. But the temperature history matched the Milankovich hypothesis predictions, And it just goes to show that these things do have an effect. When they line up, they have the biggest effect. So when you have things that are lining up, when the tilt lines up, when the inclination, or the tilt lines up, the precession lines up, and the change in the Earth's orbit lines up, you can get an ice age. In 1988, scientists analyzed mineral layers on the walls of a deep crack in Nevada, where rainwater collected for 500,000 years. They determined the age of the layers and were able to figure out the temperatures for different years. The evidence showed that the Earth began warming too early for the last ice age to have been caused by Milankovich cycles. By thousands of years even, they were off. All right, scientists struggle to understand this contradictory data, so things were not lining up. When scientists are presented with new information, we have to kind of change what's going on, or we try to confirm what we already know. All right, so this contradictory data came up. How do you reconcile this? All right, what they did, they figured out that the Devil's Hole, the data for the local climate changes in the region, they matched it with like the local climate data, and the ocean floor samples, they compared it to that. They fit. All right, so the Devil's Hole data for local climate change, they use the ocean core data for the global climate change, meaning that the local climate changes had more of an effect. So how do we know? What is the difference between science and pseudoscience? We've talked a little bit about pseudoscience before with astrology. Pseudoscience is basically a set of beliefs that on the surface seem to be scientific. These can also be, when you're talking about science, conspiracy theory type things. But most of them lack the basic scientific rigor, just basic. You dig just a little under the surface and it all falls apart. As an example, in the 1970s, people claimed that the pyramid shape, all right, pyramid shapes, just any type of pyramid shape, focused cosmic forces on objects that were underneath of the pyramid, and perhaps even had healing powers. People who really wanted to believe this idea said that fruit, if you covered it up with a pyramid structure, was preserved, and even razor blades may even become sharper, or knives become sharper if you put them underneath of a pyramid. Okay, this happened. So the evidence was there. They put it under the pyramid. It seemed like razor blade was sharper than one left out not under the pyramid. And then they found out that the fruit was preserved. An apple under the pyramid lasted longer than an apple sitting out on the counter, or even under different things. So in science, we test claims and we verify them. It was a very simple test to test the hypothesis that was this pseudoscience claim of the pyramids. Experiments show that placing a piece of fruit under a covering of any shape also helped it keep away from, germs and airborne spores and stuff in the area, and it would dry without rotting. Also, a razor blade placed underneath any shape that restricts the airflow caused less moisture and oxidation to happen, and that kept the sharpness of the blade. So, very easy to show that it doesn't just happen with a pyramid. It's not because of the pyramid, it's because you're covering it. All right? Despite those scientific contradictions, though, people still believe that the pyramid had power and could alter this stuff. All right, disregarding contradictory evidence, ignoring alternate hypotheses is a characteristic, the main characteristic of pseudoscience. Very hard to keep that in line. Let's talk about astrology for another minute here. Astrology is another branch of pseudoscience. Astrological claims have been tested again and again. Matter of fact, the biggest thing that I love is the horoscope that's connected to astrology. If you were to blind test a horoscope prediction, however many signs there are, I forget how many are in the zodiac, but they would match with almost anybody. So it doesn't have anything to do with that. They're very normal things and normal stuff that people go through, and they generally match with almost anyone. All right, there's no connection between the positions of celestial objects. And in fact, we talked about it. Most people think that constellation, even if they are into astrology, they believe that constellation is in the night sky. But it's not that. The sun is in that area of the sky, that constellation, during the day. So some people that believe this stuff even have the basics behind it very messed up. So watch out for pseudoscience. We're going to talk about more evidence at the beginning of the next video. Thanks.